Hi, in today's video, we're going to talk about part 2 of SSA, which is the ambiguous case. Please make sure to watch part 1 video before you watch this one. In part 1, a quick reminder, we said that the SSA case requires a decision. So when you have a triangle that matches the SSA case, we need to decide as a first step whether we have 0 triangles formed, 1 triangle formed, or 2 triangles formed with the given measurements. So that's the first decision. Today's video, which is part 2, is going to take this to a next step where if you have 1 or 2 triangles formed, you will be asked to solve for that triangle. So in the first step, what we're going to do, we're going to take an example of 1 triangle, and that's going to be number 17 on page 439. I'm going to give you the measurements. We're going to decide as a review for part 1. We're going to decide how many triangles are going to be formed. But I'm telling you ahead that only 1 triangle will be formed, but we will check with that. And then our next step will be to solve for that triangle formed. So first of all, let me copy the measurements given. We have angle C given as a 30 degrees, and we have side C given as 9. We have side A given as 18. So here's what we're gonna do. First of all, we're gonna draw a sketch, and I call it a sketch like a first draft because it's not an accurate view of the triangle. It could be different how it looks like, but I need a first draft to decide. So I drew the triangle, and as I mentioned in part 1 of the SSA videos, I like to put the given angle in the bottom left corner. This is angle C. Opposite side will be side C, which is given as 9. And I like to have the height, which I'm going to draw in a second to decide how many triangles. I like it to be perpendicular to the missing side in that position. Doesn't mean it's the only position that's correct to draw the triangle, but it's the easiest, I would say. So this is vertex B. This is the perpendicular from the vertex to the side, which we call height. In order to decide how many triangles we can get with those measurements, we're going to highlight this triangle and we're going to use the sine ratio. Why sine? Because the height is opposite to that given angle. And if you guys remember SOHCAHTOA, the one that includes an opposite side and a hypotenuse, because we have the hypotenuse given, would be sine. So sine of 30 degrees equals the height over 18, which is the hypotenuse, cross multiply, and you will get 18 sine of 30. By using our unit circle, not necessarily a calculator, you should find the height to equal 9. After we find the height, there are 3 scenarios. If the height is greater than the side, then there's no triangles formed. If the height is equal to the side, then there's 1 triangle. If the height is less than the side, then there are 2 triangles. And we compare the height to the side facing the given angle. So here's the given angle, and here's the side facing it. Here is the given angle, here's the side facing it. So I compare 9 to 9, and it looks like they are equal, which gives me the idea that the height is equal to the side. And in this scenario, 1 triangle will be formed, and more specifically, 1 right triangle will be formed. And there is a reason why it's going to be right, because the height is going to be a side, which means kind of pushing the H toward the S. A second better draft would look like this. That H is nothing but a side of the triangle. And this is the better draft after we did our reasoning of how many triangles we will have formed with the given measurements. This is the height. It is a side of a triangle. And some of you might ask, why did I put the 90-degree right here? Again, because I kind of took the height and pushed it to the side because that's what the reasoning gave me. But you will see that proved in the solving process as well. So if you don't understand that reasoning of why we put the 90 right here, you can just hold on until we start solving. So now I know I have one triangle. I need to solve for the triangle. So that's step 2, which is objective 2, and that's why it's in a second video. So that part 2 will require to solve for the triangle. And how are we going to solve for the triangle? We can use law of sine or cosine, but whenever possible, it's easy to use the law of sine because it's an easy ratio versus more uh, algebraically demanding equation of the law of cosine. So I like to put what I have given and what I need to find. I have angle C given, I have side C given and side A, and I'm just basically reading the given right here. And what I am missing, angle A, angle B, and side B. I'm gonna set up the sine ratio. Then I'm gonna decide which one to use. Because remember, we can use 2 at a time. And I decide depending on what I have given. I have angle C and side C, so all of this is available to me. I am missing angle A, but I have side A, so that could help. So this is how I will know that I'm using this with that. And I'll set up the ratio by writing sine of angle A over A equals sine of angle C over C. So sine of angle A, which I have missing, over the side A, which is given as 18, sine of angle C, which is given, over side C, which is 9. So now cross multiply. Remember, we're solving for sine A, and then divide. I want to keep sine A by itself. I get 2, because 18 divided by 9 is 2. Sine of 30 is half. 2 times half is 1. And I honestly don't need a calculator for this, even if like you use it. But this is something you guys should be very familiar with. Which angle on the unit circle has a sine equal to 1? It's angle pi over 2, or 90 degree, 0 comma 1, and that's the sine value. That's how I confirm that angle A is a 90-degree angle. So I solved for A. I still need 2 parts of that triangle. I need angle B, and now it's easy to find angle B because the sum of angles in a triangle is 180, or more specifically, this angle and this in a right triangle are complementary, which means they add up to 90 degrees. So if C takes 30 degrees, then 60 degrees are left for B. And I found angle B. Side B is left, so now it's time to use this ratio, sine B over B equal, I could do either A over A or C over C, whichever one you feel comfortable using. So sine of 60 degrees over side B equals sine of 90 degrees over 18. Cross multiply, then divide. and you will get what does side B equal to. And again, I don't need a calculator here because those are remarkable angles on the unit circle. So sine of 60 degrees equal to square root of 3 over 2. And the sine of 90 degrees equal to 1. And if you just multiply these, you get 9 square root of 3. And 9 square root of 3 is about 15.6. And that way we found side B. So this is the first example that includes one triangle. I'm gonna record a separate video just so that the videos aren't overwhelming of an example that has two triangles and how we can solve for two triangles.